All right, welcome everyone. All right, for this lab, you guys should have been kind of going through the different steps of reading what we're doing with the pendulum, what our independent, dependent variable are, kind of creating your hypothesis. So essentially, right, we're just going to have a pendulum that's swinging back and forth, right? So what we're going to look at is we're going to look at where do you start the pendulum, right? Kind of the starting angle, and then how long does it take to go back and forth one time, right? Change the angle a little bit higher, time it back and forth one time. So we're looking at that relationship. Where's it start? And then how long is it taking to go back and forth? So you guys should be working on this with at least one other partner or in groups of three. So between your group, you guys should have at least two different screens up. So one of them is going to be the actual lab itself. So you can access these links on Canvas. You can also just type them in from the paper to get to the virtual lab itself. Is going to be bit.ly/Watkins swing. Okay. That's going to bring you right to this page. For the Desmos graph, right, it's just going to be pretty much the same thing, bit.ly/Watkins swing graph. Right, so one of you guys should have the lab open on a computer. One of you guys should have Desmos open on a computer. Right. We'll go ahead and right-click the intro. And it's a pretty straightforward lab, right? You have your little weight here, right? You can kind of change where it starts. Right? There's a lot of other things you can change about this, right? Like the mass, the length, all that stuff. But we're going to keep it pretty simple for the purposes of this lab. So really the only things that I want you guys to do is if you go over here, right, we want to have our stopwatch. And then to start your first experiment, right, we're going to look at all these different starting angles, which you can see as we kind of raise our weight higher and higher. You can see the starting angle changing. Okay, so what we're going to do is we're going to have different starting angles. You can see we have an angle of 0, 10, 20, 30, 40 degrees. We're going to measure how long does it take to go back and forth. Obviously, for this first angle, if we're just starting at 0 degrees, right, it's going to take 0 seconds to go back and forth. Right, to measure that first real data point, right, at 10 degrees, way that we can do this, pretty accurately. Right, so obviously if you bring it to 10 degrees and you just let it go, right, back and forth, right, it's going to be hard to kind of get an accurate time if we just time it with our stopwatches, right? But if you use the stopwatch here, what we're going to start with is I'm going to have you guys press the pause button, right? And we're going to change the speed from normal to slow. On the stopwatch, we're going to hit the play button, right? And now I can bring it up to 10 degrees. And you'll notice when I let it go, right, it's just going to stay there, right, because we paused it. And nice thing about this is when I press play, is the stopwatch and the pendulum are going to start at the same time. So we're going to hit play. Right, we're going to watch it go back and forth. And what I'm going to want to do is I want to make sure I hit pause right when it comes back to its starting position. Right. Again, if you're not exactly sure, right, if it's all the way back, you have this little step forward button here that you can kind of use. Right, so as long as it's still moving to the right, then that means that's where it's going to be, right? So this looks like about right where it started. So I'm going to record this time. 1.66 seconds, right? And I'm going to do that for my other measurements, right? So I'm going to do it at 20. I can reset the stopwatch here. And same thing, right? Hit play, right? Go back and forth. I'll record the next time, right? Same thing, 30, 40, etc. And just like we've been doing in our other labs, right? Already kind of have these preset lines of best fit. So once I have all my data points, I want to go ahead and adjust my slope until I find the line of best fit, whether that's going to be a linear line, right? Or a quadratic, or inverse or other. And then I'll use whichever equation, right, defines my line of best fit, and that will be my math model.